going to have a wee look at trig identities today. Now, you're not going to like this. Nobody ever likes trig identities, okay? And I don't want you to worry too much about it. What we will do is we will spend some time in class together doing some of these questions. But unless you feel incredibly confident, don't bother going off and trying some of these on your own. Wait until we've got time together and we're all set as a class to do them, okay? You've got two trig identities. Now, a trig identity is just a rule that's true for any value at all. The first one is that sine squared x plus cos squared x equals 1. Now you can get your calculator out, and if you put any values at all in for x, this will work. So if we do sine of half squared plus cos of a half squared, we'll get 1. And whatever I change that value to in the bracket, it's going to come out as 1. It's always going to be the case, okay? So that's our first trig identity. The second one is that tan x is equal to sine x over cos x. Now, for some reason, this first one is quite straightforward to remember. The second one, people have got a habit of getting the wrong way round. So a couple of wee ways that we can remember that second one. We do sine gerene over cos gerene, we get a tangerine. Or if we do sheep over cow, then that works out nicely. The sheep can sit on top of the cow. But if we do cow over sheep, the poor sheep gets squished and it doesn't work. Okay, so tan x is sine x over cos x. Okay, as we prove the second one, we've already looked at that. Okay, what we need to do with these trig identities then is we need to use them to prove something or show that something's equal. Okay, so this one, I want to prove that 3 sine squared x plus 3 cos squared x is equal to 3. What we do when we prove something is we start with one side and we make our way to the other side. So I'm going to start just with the left-hand side, it's just this part here. So I'm going to ignore the fact that it's equal to 3 just now. So I get 3 sine squared x plus 3 cos squared x. I've got a common factor here of 3, so I'm going to take that out. So sine squared x plus cos squared x with my 3 out. That's one of my trig identities. Sine squared x times cos squared x is just 1. 3 times 1 is just 3. So that's equal to my right hand side, which is what I was aiming for. The next one, I've got 1 minus cos squared x over cos squared x equals tan squared x. That 1 here, I know that sine squared x plus cos squared x is equal to 1. So whenever I see that 1, I'm going to replace it with sine squared x plus cos squared x. Well, I should have said at the beginning here, I'm just looking at the left hand side just now. So sine squared x plus cos squared x minus cos squared x, which is just my top line with 1 replaced with sine squared x plus cos squared x all over cos squared x. Now cos squared x minus cos squared x, they cancel out. That leaves me with sine squared x over cos squared x. Sine over cos is tan. This is just sine x over cos x times sine x over cos x. So it's just tan x times tan x. So it is just tan squared x, which is again equal to my right hand side. See, sine squared x plus cos squared x all squared is equal to 1 plus 2 sine squared x. I'm going to start with my left hand side and I'm going to multiply out my brackets. So start by doing sine x times sine x, which gives me sine squared x. I then do sine x times cos x, which gives me sine x cos x. Inners, so cos x times sine x. Sine x, cos x, sine x, same thing. So I'm just going to write this around the same way. So I get sine x cos x. And my last cos x times cos x is cos squared x. Tidying up then, that gives me sine squared x plus cos squared x. Then I've got two of these, so I get 2 sine x cos x. Sine squared x plus cos squared x is just 1, so we get 1 plus 2 sine x cos x, and that equals my right hand side. Okay, next one. I want to express the following in simplest form. I prefer the prove that ones because we know exactly what we're aiming for, but here we're just trying to think what we can replace and try and make it as simple as possible. We know that tan x is equal to sine x over cos x, so I can replace my tan x with sine x over cos x. That means I'm timesing by cos x, I'm dividing by cos x, they cancel each other out, so I'm just left with sine x times sine x. This is sine squared x. B, got 1 minus sine squared p over 1 minus sine. Okay, the second one then, we've got 1 minus sine squared p. I'm going to replace my 1 on the top line with sine squared p plus cos squared p. I'm not going to do it on the bottom line because it doesn't have a squared in it, so that won't simplify it down any. So I'm just going to leave that bottom line as 1 minus sine p for now. Sine squared p are going to cancel out, so that leaves me with cos squared p over 1 minus sine p. Actually, nothing else I can do with that one, so it's just going to stay just like that. See, I've got sine x minus cos x all squared plus 2 sine x cos x. I'm going to start by multiplying out the brackets. I'll do this just using FOIL. I'll write out my 2 brackets. If you can square the quick way, then square the quick way. Saves you some writing. So multiplying out my brackets would give me sine squared x minus sine x cos x minus sine x cos x plus cos squared x, and we've got plus 2 sine x cos x tagged on the end from here. Tidying that up, that gives me sine squared x, I bring my plus cos squared x over, plus cos squared x minus sine x cos x minus sine x cos x is minus 2 sine x cos x plus 2 sine x cos x. They're going to cancel. So I'm just left with this sine squared x plus cos squared x, which is 1. So that whole thing just simplifies down to 1. Okay, again, please don't worry about these trig identities. We will do some as a class and then we'll move on. It's only ever worth one question. It's one of these topics that's really in National 5 because we need it for higher.